Notice again, I can mimic the usual traditional trigonometry. I can define the tangent of t to be the number sine t divided by the number cosine t, etc. And I'll leave those details to the reading material. I can ascertain rather interesting results the same way as I could in regular traditional trigonometry. In fact, I can get some certain results very nicely. I remember, for example, well, I won't even go into this, but how did you talk about the sine of 0 when one talked about traditional trigonometry? How did you embed a 0-degree angle into a triangle and things of this type? Notice that in terms of my tradition here, that, well, and we'll summarize these results in a minute, but notice, for example, that the sine of 0 comes out to be 0 very nicely, because when t is 0, the length 0 terminates at s. S is on the x-axis. That makes what? Y equal to 0. Notice also that if the radius of my circle is 1, the circumference is 2 pi. So, for example, what I usually think of a 90-degree angle would be the length pi over 2. And without making any fuss over this, again, leaving most of the details to the reading and to the simplicity of just plugging these things in, we arrive at these rather familiar results. We also get very quickly, in addition to these results, things like the fundamental result that we always like with trigonometric functions, that sine squared t plus cosine squared t is 1. And how do we know that? Remember that cosine t was just another name for the x-coordinate at which the point terminated on the circle. In other words, notice that cosine squared t is x squared, sine squared t is y squared. The x-coordinate and the y-coordinate are related by the fact that what? The sum of the squares to be on the circle is equal to 1. We could even graph sine t without any problem at all. Namely, we observe that when t is 0, sine t is 0. Notice that as we go along the circle, the sine increases up until we get to pi over 2, at which it peaks at 1, then decreases at pi, back down to 0. And if that's giving you trouble to follow, let's simply come back to our diagram to make sure that we understand this. In other words, all we're saying is as t gets longer, its y-coordinate increases from 0 to a maximum of 1 when the particle is over here. Then as t goes from pi over 2 to pi, the length of the y-coordinate decreases till it again becomes 0. And again, without making much more ado over this, we get the usual curve that we associate with the sine function, even when we thought of it as a traditional trigonometric problem.